Let's learn how to use tree diagrams to calculate probabilities. It happens that tree diagrams are a great way to show all of the different possibilities and figure out probabilities when there are two different experiments, two steps to an experiment. Let's see how they work. In this scenario, Mr. Ranieri is still trying to guess the multiple choice question and the true or false question. This is one we looked at a while ago in 15D when we were looking at sample space. Anyway, for the multiple choice question, he has a 1 in 4 chance, a quarter chance of getting the question correct. And he has a 1 in 2, a half chance of getting the true or false question correct. Create a tree diagram and calculate the probability of each outcome. Okay, so for a tree diagram, we first put at the top the two different steps of the experiment. The first step is that Mr. Ranieri does the multiple choice question, and the second step is the true or false question. Let's list all of the outcomes for the multiple choice question. Well, either he gets it correct or he gets it incorrect. These are not equally likely. It says there's a quarter chance of getting it correct, but there's a quite likely chance you'll get it wrong. Let's list those probabilities on these branches here. So the two outcomes are correct or incorrect. The chance of this thing happening is a quarter. So the chance of it being incorrect is 3/4. 1 whole, take away a quarter, leaves 3/4 left. Now let's look at the next step, or the next experiment, which is the true or false question. Again, if Mr. Ranieri gets the first question right, still in this second question, the two outcomes are that he could get it correct or incorrect. And if he gets the first question wrong, the true or false question, the second one, could still be correct or incorrect. Suppose that Mr. Ranieri got the first question right. What's the chance that he gets the second question right? Well, he's just picking randomly. So there's a 50% chance, there's a half chance that he gets this question right, and, a 1/2 chance that he gets it wrong. And the same down here. He's just guessing randomly. The fact that he got it wrong the first time doesn't affect the chance that he's going to get it wrong in the second question. So these are the same, a half and a half. These events are mutually independent. They don't affect each other. Now we've got the probabilities on each branch. Let's figure out the probability of getting the first question correct and the second question correct. To figure out the probability of these two things both happening, it is this probability multiplied by this probability. You go down the chain, a quarter times a half. And a quarter times a half is 1 times 1 is 1, 4 times 2 is 8, 1/8. Let's try another one, this one here. I go down the chain, a quarter times a half is, this is just the same. So there's a 1 in 8 chance that I get the first question right and the second question wrong. What about this one? Well, if I go down the chain, I've got 3/4 times a half. 3/4 times a half. 3 times 1 is 3 on the numerator. 4 times 2 is 8 on the denominator. So there's a 3 in 8 chance that I get the first question wrong, but the second question right. And I can do the same for the last one. 3/4 times 1/4, which is the same. You can see that some of these outcomes, like getting the first one wrong and the second one right, is more likely than this one, which is getting the first question right and the second question right. Now we can answer questions like these to determine the probability for these events. For example, what's the chance that Mr. Ranieri gets both questions correct, even though he's guessing randomly? What are the odds? Well, the probability of getting both correct means that I have to get the first one correct, and I also have to get the second one correct. So only this outcome here matches what I'm looking for. You know, I got the first one right and the second one right. So the chance is 1 out of 8. Where's the working? Well, I put the working over here. That's where my working out is. What about the chance that Mr. Aneri answers at least one question correctly? You know, maybe he has to get at least one question right to pass. What's the chance? Well, the probability of at least one question correct is any of these. Let's go through one by one. In this outcome, this one here, there we go, this one. Boop, 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 boop. In this one, he got the first one right and the second one right. Did he get at least one right? Yes, he got both right. And in this one here, I got the first one right and the second one wrong. So I still got at least one question correct. And this outcome here, I got the first question wrong and the second one right. So I still got at least one question answered correctly. So all three of these outcomes match what I'm looking for. So the probability is the chance that this will happen, 1 over 8, plus the chance that this happens, 1 over 8, plus the chance that this happens, which is 3 over 8. You add them together. 1 over 8 plus 1 over 8 plus 3 over 8 is 5 over 8. And that is how you can use tree diagrams to calculate probabilities of what are called two-step experiments, where you've got your first step here and the outcomes, and the second step here and the outcomes, and you can figure out the chance of all of the combinations. For example, the chance that I get this one here represents the chance that I got the first one correct and the second one incorrect. I hope this has been helpful. If you have any questions, let me know. Good luck, get some practice, and I'll see you in the next video. Bye, everyone.